Alrighty, Mr. K here. I am going to be talking about exponent rules, and this is going to be the first page in your packet, aka the front page, aka the graphic organizer that we are going to be working with. We'll need this for the next page, which is going to be the practice problems. Now, the first rule for exponents is to make sure that we combine like terms. So remember that back in Unit 1, our very first units in the very first day, we talked about how we do not change common variables and exponents, and we just leave them like they are. So in this case, I'm going to go ahead and highlight my 9 and my 10, aka my coefficients. I have my variables that I'm going to keep the same. So I'm going to have x squared y. I'm going to keep them the same. And then I'm going to do 9 minus 10, which is negative 1. Number 2 says subtract 6w from 8w. So this is saying 8w minus 6w, which is equal to 2w. All right. So that was adding and subtracting monomials, aka combined like terms. Easy peasy lemon squeezy. The next rule that we're going to be doing is the product rule. So let's look at number 1 here. What I'm going to do first is expand h squared and h to the 6. We know that h squared is just h times h. So I'm going to say h times h. So I'm going to highlight this right here. And I also know that h to the 6 is the same thing as saying h times h times h times h times h times h. So we have 6 of them. Now, if we count the total number of h's, you'll see that we have 1, 2, 3, 4, 5, 6, 7, 8. So this means that this is equivalent to h to the 8th power. So, whenever I am multiplying, you'll notice that we will probably have to add our exponents. So instead of me expanding h to the 2nd power and doing this 2 times, and expanding h to the 6th power and expanding it 2 times, you'll notice that we get h to the 8 by adding 2 plus 6. So what I'm going to do here is say x to the a plus b. So that's my rule, where x is going to be my base, your a and your b are going to be your power, your exponents, and then add them up. So a plus b. Now it's important that we are only adding the exponents, okay? And we're adding the exponents with like terms. Now, whenever we are multiplying numbers here, multiplying coefficients like negative 2 and 7, I'm multiplying them like a regular number. So negative 2 times 7 is negative 14. Now, with a to the 2nd power and a to the 3rd power, I'm going to add them, and that's going to give me a to the 5. Notice how I did not add 1 and 1 here, because b is a different term. Remember that your exponent, if you don't have an exponent, is 1. So this is the same thing as saying b to the 1 times b to the 1. If I add my exponents, 1 plus 1 is 2. So I get b to the 2nd power. And that is my final answer. All right, so for number 3, we want to look at the power rule here. So what I'm going to do here is I'm going to expand this out. So the first thing that I'm going to do is, this is saying I have to make 3 copies of x squared. So I'm going to do x squared times x squared times x squared. Now remember that x squared is the same thing as x times x, x times x, x times x, which gives me x to the 6. Now, if you didn't want to expand this, remember that you guys could have also done the product rule, where we could have done 2 plus 2 plus 2, which gave us 6. Now, to shorthand this, you'll notice that 2 plus 2 plus 2 is 6. And we might think about how 2 times 3 is 6. So whenever we are using product rule here, whenever we have a power to a power, we are going to multiply the exponents together, given that we have the same base. Remember that if we don't have the same base, then we can't do any of the rules. So like remember how on number 2, we had a square and a to the third, which gave me a to the fifth. B1 and B1 gave me B squared. So we just want to make sure that they are the same variable. Now, one thing that's important here is whenever we do a power to a power, we're only doing it to the exponent. So with the coefficient, we're doing it like a regular power. So here, whenever I look at -2, and I have a square, this is a regular -2 square right here. And I have m to the fifth square times m to the third. So notice how I'm going to multiply 5 and 2, and that's going to give me 10 right here. But with this 2 here, whenever we have a regular base, we are going to just use my regular exponent properties. So -2 squared is 4. We know that 2 times 5 is 10. And we have m to the third. Using my power rule now, I'm not going to expand this 10 times, and I'm not going to expand this 3 times. Hopefully we know now that we can add our exponents here and here, because it's multiplication right here. This gives me 4m to the 13 as my final answer. All right. 1, 2, 3, 4 is going to be the quotient rule. So I'm going to look at this right here. I'm going to expand x to the fifth, and then I'm going to see what happens there. So if I expand x to the fifth, I get x times x times x times x times x over x. We're going to look at pairs on top and on the bottom. So that's going to cancel out, which means that I only have 4 x's. X times x times x times x, which is going to be x to the fourth. Which means if we look at my exponent here, a 5 and a 1, we are going to subtract. So 5 minus 1 is 4. X to the a over x to the b, x to the a minus b. And remember that you have to have the same base. If they are not the same base, that's not good. Now, there is one thing that we haven't done yet, and that's look at 27 and 42. You're going to see that 27 and 42 have a GCF of 3. So I'm going to divide 27 by 3. And I'm going to do 42 divided by 3. 27 divided by 3 is 9. 42 divided by 3 is 14. So this is 9. This is 14. Since this is a fraction, our final answer is going to be 9 over 14, x to the fourth. All right. Number 2, we have to do the power rule first. So if I do y to the second power, that's going to be me multiplying. That's going to give me y to the fourth over y to the fourth. Now, y to the fourth over y to the fourth, you could do two things here. If I were to expand this, I'll get y times y times y times y over y times y times y times y times y. And you'll notice that we have an equal amount of y's on top and an equal amount of y's at the bottom, so they all cancel out, meaning that I'm just left with 1. Now, if you use the quotient rule, where we do a minus b, we'll get y to the 4 minus 4, which is y to the 0. And remember that anything to the 0 power is going to be 1. Which kind of leads us to this right here, the 0 exponent rule. Anything to the 0 power is 1. So for number 1, 7 times x to the 0 is 7 times 1, or 7. Same thing with number 2. This is a power to a power, so we are going to multiply w to the 8, w to the 8. That's the same thing as saying 8 minus 8, or w to the 0, which is 1. All right, last one, the negative exponent rule. We do not like it whenever we have a negative as an exponent, so we are going to either bring it down or bring it up depending on where your negative exponent is. In this case, I am going to move the exponent to the denominator, and that's going to give me 1 over x to the a. Now, if you have an exponent that is negative in the denominator, I'll just bring it up. So this is x to the a. So looking at number 1 here, where we have negative 5x to the negative 2, one thing that we want to make sure that we are doing here is not to bring down the negative 5. We only want to bring down whatever is next to the negative. In this case, we're only bringing down x. So I'm going to have negative 5x squared. Notice how that negative 5 stayed up as a coefficient right there. So we would just leave it as negative 5 up top. For number 2, we have 4 over 8. So I'm going to simplify that down to 1/2. Now, I also know using my quotient property, because it's division, 2 minus 5 is negative 3. I have k to the negative 3. I'm going to bring down k to the negative 3 because I don't like negative exponents. So I get 1 over 2k to the 3rd. That's my final answer. All right, so in the next video that we are going to do, it is going to be the practice page here. So we are going to simplify, and our answer should only contain positive exponents. So this is going to be a lot, but we'll pick and choose and see where that takes us.